Have you ever just looked up at the night sky and been totally blown away, wondering if you could ever capture that cosmic beauty for yourself? Well, guess what? You absolutely can. Today, we're going to dive deep into the incredible world of backyard astrophotography. Okay, just take a second and look at this. This isn't CGI. This is a real photograph of the Whirlpool Galaxy M51. It's vibrant, it's packed with detail, and it's millions of light years away. When I first saw an image like this, my first thought was probably the same as yours right now. How? How is a photo like this even possible from right here on Earth? It looks like something you'd need the Hubble telescope for, right? But what if I told you that the journey to creating images like that doesn't start in some high-tech mountaintop observatory? Nope, it starts with someone just like you in their own backyard. So can you really capture the universe from home? The answer is a huge, resounding yes, and we're going to show you how. Okay, let's get into it. Before you can capture anything, you've got to tackle the very first and maybe the most important challenge of shooting at night: getting a sharp focus. This is your first real step into the cosmos. I mean, think about it. During the day, your camera's autofocus is amazing, right? It can lock onto a bird in flight, no problem. But at night, your camera is completely lost. It has nothing to grab onto. You're not trying to focus on a flower. You're trying to focus on a tiny pinprick of light that's traveled for millions of years to get to you. So how in the world do you do that? Well, the most common starting point is a feature on pretty much any modern DSLR called Live View. It's simple, really. You just point your camera at the brightest star you can find, use the digital zoom on your screen to punch in on it, and then you very, very carefully turn the focus ring on your lens until that star is the smallest, tightest little dot of light it can possibly be. Now, live view is a great start, but it's a little bit of a guessing game. Is it really as small as it can get? For true, dead-on, pinpoint accuracy, astronomers and serious photographers use this deceptively simple and honestly brilliant tool. This is it. It's called a Botanov mask. I know, it looks kind of like a weird piece of modern art, but this little gadget is an astrophotographer's absolute best friend. You just pop it right on the front of your lens or your telescope. So how does this clever thing work? Well, when you point at a bright star with the mask on, those little slits create this really unique three-pronged starburst pattern. Your only job is to adjust the focus until that middle spike is perfectly, exactly centered between the other two. There's no guesswork at all. When it's centered, boom, you're in perfect focus. It's just an incredibly smart and foolproof solution. All right, you've nailed the focus? Awesome. But now you're up against your next big opponent, the planet Earth itself. To get those glorious deep space photos, you have to learn how to fight back against the Earth's spin. You see, the Earth is spinning at about 1,000 miles per hour. We don't feel it, but your camera sure does, especially when its shutter is open for a long time. The result? You get those blurry star trails you see on the left. To get the image on the right, with those beautiful, sharp, pinpoint stars, you have to trick your camera into thinking the sky is standing perfectly still. And that's exactly what a tracking mount is for. It's a special tripod head that you line up with the Earth's axis. Then, as the Earth spins one way, the mount slowly, precisely spins your camera the other way, at the exact same speed. It perfectly cancels out the Earth's rotation, basically freezing the stars in place for your camera. It's pretty amazing. Now, these mounts come in a few flavors. You can get started with a basic, portable star tracker for a few £100s. Then you have what are called go-to mounts, which are really cool. They can automatically find and point your telescope at thousands of things in the sky. And for the really serious folks, there are heavy-duty mounts that give you unbelievably precise tracking. The bottom line is, there's an option out there for pretty much any budget. Okay, so you've focused, you've tracked the stars, you've taken your pictures. You might think you're done, but in a lot of ways, the real work is just getting started. Welcome to the magic of post-processing, where you get to reveal a hidden universe. The first time you look at an image straight out of your camera, you might be a little disappointed. It'll probably look pretty dark, kind of gray, and that amazing nebula you were so excited about might be barely visible. But don't worry, that's just the raw data. Think of it like a block of stone. The beautiful sculpture is hidden inside. You just need the right tools to bring it out. And this right here is the perfect example of that transformation. On the left, that's a raw image of the Pleiades star cluster. Yeah, you can see the stars, but it's pretty flat. Now look at the right. After processing, suddenly all that faint gas and dust just pops. The sky is a deep, rich black, and the colors are incredible. That is the magic of post-processing. So how do you get from A to B? Well, it involves a few key steps. First, you stack a whole bunch of photos, sometimes dozens or even hundreds, right on top of each other. This is an amazing trick to get rid of all the random digital noise. Then you use tools in software like Photoshop called levels and curves to stretch the data, making the faint stuff brighter and the dark sky darker. Let's just zoom in on one of those tools. This is the levels adjustment. See that little graph? By simply moving that slider on the far left, the black point, you're telling the software, hey, anything this dark or darker should be pure black. In one simple move, you clean up light pollution, you darken the sky, and you make your stars and your galaxy just pop right off the screen. Taking one great photo is a massive thrill, but the real long-term joy of this hobby, it comes from building a collection of images over time. So, in this last section, let's talk about going from a single picture to curating your very own cosmic gallery. I love this quote from a university student's project plan. It really highlights a key idea here. It's not just about taking pictures, it's about building a meaningful collection. By planning to shoot different types of galaxies, this student is thinking like a curator, not just a photographer. And that mindset can turn your hobby into a really rewarding long-term project. But hey, you don't need to be in an astronomy class to do this. The whole idea of a gallery is just about organizing and showing off your work. And you can start creating and curating your very own cosmic collection with a tool you use every single day, your phone. For example, here's a neat little trick on a Galaxy phone. Let's say you took a great picture of the moon and a separate one of the night sky. You can open that moon photo, copy it, then open your night sky photo, and here's the key, before you go into edit mode, just long press on the background and you can paste the moon right in. It's a simple, fun way to start thinking about creating composite images. And as you take more photos, start getting them organized. Create a special astrophotography album in your gallery app. You can easily transfer your files to a computer with a USB cable for more powerful editing. For your absolute best shots, maybe use something like a secure folder to keep them safe. And most importantly, share your work. Inspire other people to look up. It's all a journey. Every single breathtaking, award-winning photo you've ever seen of a distant galaxy started exactly where you might be now, with a camera, a dark sky, and that very first step into the night to try and get things in focus. So the most important thing to take away from all this is that it's totally within your reach. The universe is up there just filled with wonders waiting for you. The only real question left is, what are you going to capture first?